So good morning, everyone, and welcome to this lecture. This is not lecture number 2. This has to be lecture number 3. Lecture number 3 on waves. And in the previous class, we were dealing with the wave equation. And remember, the most important aspect of this chapter is understanding the wave equation. If you understand the wave equation, and I hope you have got sufficient time to remember these simple things, because a question from this part is more likely to come from this wave equation part, or it will be from the part of standing waves where we talk about harmonics and overtones. Anyways, let us first get through this part, and I hope that by the end of today's class we are done with this wave equation so that we can move ahead in our lives. But before moving ahead in our life, we'll have to solve questions that make us confident of this wave equation. And we had dealt with various type of problems. We'll continue on those problems. Let me give you this one first to start off the proceedings. Okay, so this is the problem. This is just to get you in tune with the wave equation. The displacement of a particle performing simple harmonic motion. So this is simple harmonic motion. Anyways, what is the frequency of the motion? This is just to make you understand that simple harmonic motion and this wave equation are similar. The only difference is simple harmonic motion, we were only seeing the motion of one particle. Here we are seeing the motion of all the particles, and I will explain to you how that happens. So what is the frequency of this wave? What is the answer?
D, sir.
D is the answer. The frequency is 2 pi hertz. It's very 2 hertz is very easy to understand. You must remember that whatever comes with this t, whatever comes with this t is omega. No matter is the equation of simple harmonic motion or the equation of a wave, the coefficient of t is always omega, and the coefficient of x is always k. If you remember that, things become simple. This is omega, and omega is 2 pi f. So omega divided by 2 pi will give you the frequency. Everyone got this, yes or no?
Yes, sir.
This is the next one then. A wave is represented by the symbol this is this, where x is in meter and t in seconds. The speed of the wave is.
A, sir.
I think we have done this question before.
Yes, sir.
Okay. I forgot it. I thought that I have done it. Now this is a question from your previous year IITs, and it may have more than one option correct. So remember, these are the most difficult type of questions, the multiple choice, because if you mark any option wrong, you get negative. So this is a multiple option correct question. Question number 3. A wave is given by the equation of this, where x is in meter and t is in seconds. What does this represent? I'll give you a minute to give me the answer. So the answer is option
B and C.
option B and C are absolutely correct. Remember, there is a positive sign in between these two terms. So this wave has to be traveling in the negative x direction. These are the only two options which has negative x, and therefore these two options definitely become wrong. In B option, they are asking you the velocity, and in C option, they are asking you the wavelength to get the velocity. Remember, again, this term is omega and this term is k. How do you get the velocity? Velocity can be written as omega by k, yes or no? And k is 2 pi by lambda. From here, you can find out lambda. Lambda will be equal to 2 pi by k. You just have to put the values, get the answer, and stay happy. Do we understand this? Or it has gone above our head saying bye bye, sir. I'm going, sir. Bye bye, sir. Huh?
We understood.
Paka?
Yes, sir.
Okay. So now I think we are getting used to this wave equation. That was the entire concept of doing these questions. One more. Give me the answer first. Question number 4. The equation of a wave is given. You have to tell me its wavelength.
B, sir.
Yes, sir.
Option B.
Option B, that is correct. 2 centimeters. Again, how did you get it? Whatever comes with this, I mean, pi is also outside, so pi will be coming inside. This is equal to k. So k is your pi, and that is 2 pi by lambda. Yes or no? So
Yes, sir.
here we get the answer and we get the answer correctly. Okay, one more. Question number 5. This is single option correct, so there are not multiple options correct here. Only single options correct. Which one is the correct option?
Option C, sir.
Option C. Remember, we see this wave. There is a positive sign, but there is a y here instead of x. So this must be traveling in negative y direction. There is only one option which has a negative y direction. So that is the correct option. You don't even have to find the wavelength here. In any case, this 12.56 was k, and that was always 2 pi by lambda. Do we understand this? Yes or no?
Yes, sir.
Okay. Here comes the next one. Question number 6. What is the answer for this one? The equation of a wave traveling on a string is this. Don't have to write the question, just give me the answers. What is the velocity or the speed, wave speed? What is the wave speed?
D, sir.
D, sir. Anyone got the answer, sir? Do we understand this? You just have to find out the velocity. It is, you can see there is a negative sign in between, so it has to be option C or D. And you can easily find out the velocity of the wave omega by k, coefficient of t divided by coefficient of x. We understand this, everyone?
Yes, sir.
Okay. Then we move on to this. This encompasses everything that we have done till now. So let's see if you can do this question. The question comes on your screen now. Question number 7. A sinusoidal wave traveling in the positive x direction has an amplitude of 15 centimeter, wavelength of 40 centimeters, and frequency of 8 hertz. The vertical displacement of the medium at t is equal to 0 and x is equal to 0 is also 15 centimeters as shown. And then these are the things that you have to find out. I will give you 2 minutes to give me the answer.
Pi by 20.
Yes, give me the answers. Now,
Angular wave
angular wave
number is
number is k. Yes, what is this?
pi by 20, sir.
How much?
Pi by
Pi by
20.
20. Okay, accepted. Answer matching. Yes.
Period is 2 pi, sir.
Okay, time period.
Sir, that is period or time means
This is time period.
time period. It is time period.
Period means time period.
1/8 seconds, sir.
1 by 8 seconds. Okay. Angular frequency.
16 pi.
16?
Pi.
16 pi. Accepted. Speed of the wave.
320 centimeters per second, sir.
320 centimeters per second. Now comes the last part. Determine the phase constant and write a general equation for the wave function.
Sir, phase constant is pi by 2, sir.
Okay, good. And what is the general equation?
Y equals to 15 sine
15
16
sine
16 pi t
16 pi t
minus pi by 20 x
minus pi by 20x.
plus
Oh,
pi by 2.
very good. So we have understood this equation, everyone. We got this. How did we write this? Looking at the position of one particle at one time, we could write the equation of all the particles at all the time. Do we understand this, or this is gonna power at saying bye bye, sir? Do we understand this or no?
Yes, sir.
Okay. One more question just to. Anyone got the answer for this one? No? Okay. Question number 8 coming on your screens now. Give me the answer for this one, and then we will move ahead with other things in life. I'll give you 2 minutes to do this. Okay, so tell me the answer so that we can compare. Yes. What is the speed? Speed of the wave?
3.33 meter per second.
3.33 meter per second. Okay. What is the direction?
Positive direction of x-axis.
Positive x. What is the vertical displacement of the string at t is equal to 0 and x is equal to 0.1 meters?
Minus 0.30. minus 0.350 into sine of 9 degrees.
Okay, so basically what you got to do is put t as 0 and x as 0.1. Yes or no?
Yes, sir.
So if you put t as 0, it is 0. X as 0.1, it becomes 0.3 pi. What do you mean by 0.3 pi? How much is 0.3 pi?
3 pi by 10.
3 pi by 10. How much is that? Okay, 3 pi by 10. So you can just write the value of y as 0.35 sine of pi by 4 minus 3 pi by 10. Yes or no?
Yes, sir.
Okay. What is the wavelength and the frequency of the wave? Huh? I gave you so much of time and you could not calculate.
2 by 3 meters, sir.
2 by 3 meters. Frequency F.
Frequency is 5 hertz.
Okay. So we understand how we get this? Yes or no? Yes or no?
Yes, sir.
Okay. Now we see here by putting the value of time and by putting the value of x, we got the displacement of any particle. Yes or no? Now let us try to understand the wave equation once again. Now, if I write a general wave equation in the form of y, so I will write it like this. Y will be written as a function of xt, and if I write it in general form like this, a sine omega t minus kx plus phi. Now, putting the value of t and putting the value of x, you can find out the position of any particle at any time. Yes or no?
Yes, sir.
You can find out the position of any particle at any time. Now, see how this equation comes into the picture. If I put, let us say, t is equal to 0, or let me not put t is equal to 0. If I just put x is equal to 0 in this equation, if I put x is equal to 0 in this equation starts to look like this: sine of omega t plus phi. Now, what does this equation represent? So that you will be able to understand what the entire thing represents. What does this equation represent?
SHM, sir.
Of what?
Of a particle.
Where is that particle?
At x equal to 0.
Yeah. So this now is equation of SHM of particle which is present at x is equal to 0. Do we understand this? It will give us it will give us the position of the particle x is equal to 0 at all times. Yes or no? No, yes. Do we understand this, or this is going above and saying bye bye? Sir, ho gaya, bye bye.
Yes, sir.
Bye bye.
We understood.
Okay. So if I have to draw, it will just look like this. It is just a sine wave, and it will look like this. This is the graph between t and y for a particle which is at x is equal to 0, and you can find out its position at any time. I have just taken phi as 0 also, so that the initial phase is 0. I have taken phi as 0 also. You understand how I have drawn this? This is simple equation of one particle as a function of time. We get this? Do we get this?
Yes, sir.
Now let me do the next thing. What is the next thing? If let us say I put time as 0, then I write this equation. Y is a function of x and t. That will now look like a time as 0, and also let me write the phi, the initial phase as 0. Here also write phi as 0, so that the initial phase is 0. Then I get x is equal to a into sine of minus kx, right? Sine of minus kx is minus sine kx. Yes or no? What does this equation represent? This is the equation of y as a function of x. Again, this is a sine wave. But what does this represent? Let me add here at all times, because if I change the value of time, we will get the equation of SHM. What does this equation represent? Here I have kept the time as 0. Time is fixed. Y is a function of x. What does this equation give us? This equation gives us what? The snapshot or the picture or the shape of the wave at time t is equal to 0. It gives us the position of all particles at time t is equal to 0. Do we understand this? What I am saying here? So if I now draw a graph between y and t, it is negative sign graph. So I will have to draw the graph in the reverse order. This is the shape of the wave. This is how the wave looks. Shape of the wave at time t is equal to 0. I plotted it wrongly. Here it should be x. So you just put the value of x from 0 to infinity, and you will get the shape of the string or the shape of the wave at time t is equal to 0. Do we understand what is meant by this wave equation, or it has gone above our head saying bye bye sir? What ho gaya sir? Leave me sir. So when I put the value of time as fixed and I change the value of x, I will get the shape of the wave at that time. If I put a constant value of x and change the value of time, I will get the SHM of one particle at all times. If I change both, if I put a random value of x and a random value of t, I will get the position of that particle at that time. Do we understand this, or it has gone above our head saying bye bye?
Understood, sir.
Everyone understands this? Okay, so if you understand this, half of the battle is won, because we now understand the basics of this wave. But remember, this wave consists of particles which are doing SHM. Now we come to velocity and acceleration of particle. Velocity and acceleration of particles. They are particles. There are particles on this wave. In the medium, there are particles, and those particles are performing SHM. We know that. How do I find the what? The particle velocity and particle acceleration. Let us say that my y, it is a function of x and t. My equation look like this. Let me add a phi as well, initial phase. Now I have to find out the velocity and acceleration of a particular particle at a particular time. How do I find it? All particles will have different velocities, different acceleration, different displacement at different times. How do I find it? How do I find the velocity of the particle or the acceleration of any given particle?
Differentiating displacement and double differentiating displacement will give velocity and acceleration respectively.
But here are two variables. T is also a variable, x is also a variable. So how will I differentiate it? So to get the velocity of a particle, remember we are talking about a single particle now. We're talking about a single particle now. We are talking about a single particle now. We are talking about a single particle now. And since we are talking about a single particle, the value of this x, where the particle is present, because the particle does not move. Do we understand this?
Yes, sir.
So the value of this x is constant, yes or no?
Yes, sir.
Because even if the particle is moving ding 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 like this, or it is moving ding 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 like this in a longitudinal wave, the mean position remains there. The particle actually does not go. It just oscillates, yes or no? So
Yes, sir.
basically what I need to do is I need to differentiate this, but it is not a complete derivative. It is a
Partial.
partial derivative. Keeping what constant? X is a constant. Do we understand this, or this has said bye bye? Bye bye. I'm going. We understand this or bye bye?
We understood.
What is the partial derivative of this with respect to t? X is constant. You have done differentiation, yes or no? Huh? No one has done differentiation. So it will come as a omega cos, only t is the variable, rest else is a constant. So 1 omega jumps out of the integral and you have a omega. Now this is exactly same as the equation of SHM. The only thing is x can be 0, can be 1, can be 2, can be 3. So what does this a omega become? Huh?
Maximum velocity.
Maximum particle velocity, Vmax. And where does the particle have maximum velocity? Where does the particle have maximum velocity? No one knows it.
At A. Mean position. Sir, at mean position, sir. Means what is that mean position? See next question.
It has The maximum velocity at mean position. Why you have to think so much? Okay. To get the acceleration of the particle, what do you do?
Sir, there is no need of inner differentiation, sir. Here.
Take a deep breath. Open your eyes and see what I have done. Take your time. That is why I take your time. Let me do the derivative. Let me do the derivative and then I'll give you time. So you take a deep breath. Take a deep breath and then you see what is there. So this will become minus a omega square sine of omega t minus kx plus phi. And what is this a omega square? Huh?
A
This is
max, sir.
particle ka maximum acceleration. And where does that happen?
Extreme position.
At the extreme position. And you can now see that you can write this as minus omega square into y. So this is definitely a SHM and the particle execute SM. Now coming back to your question, inner differentiation, why didn't I do? Did I do it or not?
Yes, sir.
See, when you open your eyes, you see the universe. Universe is wonderful. 4% of which we see, 96% is dark matter. The only thing that can be differentiated is only omega into t because t is the variable. Rest all are constant, so I don't need to differentiate them. Do we understand this? Or bye-bye?
We understood.
See, understanding on yourself is so good. You will never forget it. This is how you get the particle velocity and particle acceleration. Do we get this? Yes or no? No, yes. I'll give you 2 minutes to note this down. Do the derivative on your own and see it with your own eyes and do it with your own hands. 2 minutes you have. Now, since we have differentiated it partially with respect to t, now we can also differentiate it partially with respect to x. So that is a derivative that you have to do on your own and tell me what will be the derivative of y with respect to x, keeping t as constant. Yes. And if you did not get this, that means you cannot do the derivative and you have not understood how to do partial derivative. Yes. Time is running out. What is the partial derivative of y with respect to x? T is constant. Let me write that also as well. Yes, bacha. So that is basically giving us the shape of a wave at any time. Yes. We don't know. Huh? It will be minus k into a into cos of omega t minus kx plus phi. Is it so difficult to differentiate sine function? Huh? That you cannot differentiate sine function. Okay. I always believe that students are like cash vouchers. Sometimes they may not work. Sometimes they might work. So now you get one more chance to double differentiate it. Find out the double derivative, double partial derivative, d del 2y by del x square. And you have this chance. This is sale time. Ganga ji mein, when you go to Ganga and you take a dip in holy Ganga water, all your sins are erased. So this is a sale at Ganga. If you can give this answer, all the sins of your this class of not doing the partial derivative in the first attempt get erased. Sale offer at Ganga. Take one dip and clear sins of 5 lifetimes. Yes. What is the second derivative? Second partial derivative of y with respect to x. Sale is on. Sale is on. Sale is on. Anyone with an answer? Second partial derivative. No one knows how to differentiate it. So it's my turn to do it. It will be minus k square a sine of omega t minus kx plus phi. And I will not explain how this is done because you will have to figure it out on your own.
Sir, it will be plus, no, sir.
Take a deep breath. Open your eyes. See which function you are differentiating. See what is inside. See what will come out. Deep breath will help. Deep breath always helps. It helps, no? Now, comparing the two equations, which I am going to compare. Which one I am going to compare? The two yellow ones. Because these two yellow ones are the first partial derivatives. We see a striking.
Sir, that yellow ones are not marked.
We will see a striking resemblance between the two. What striking resemblance? And does not require rocket science. Just have to open your eyes, take a deep breath, and look at the wonderful universe that is there in front of you in the term of a whiteboard. Yes. What resemblance do you see? Huh? So we see nothing. We are colorblind. We see this one. Del y by del t at constant x will be equal to minus omega by k times of del y by del x. A very, 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 very important result.
Sir, that I observed, but I am in a confusion that what is del y by del x is representing.
It is not representing anything. It is just a partial derivative of y with respect to x at constant t. That tells us how y varies with x. How does the graph look like of
Means
y with
like
x? How does the shape of a wave look like at a constant time?
positive, negative, increasing, decreasing, like that, sir.
What positive, negative? It's a cos function, nothing else. It's a cos
I
function.
mean, it is above positive x-axis or below positive x-axis. I mean,
It's
it
a
says
cos
something
wave.
about.
It's a cos wave. Just a cos wave at a constant time. You put the value of time as something and just change the value of x. It's a cos wave.
Okay, sir.
It's a cos wave, nothing. It's a sinusoidal thing. It's a cos wave. You just have to draw a cos wave. Now, if you open your eyes again, your del y by del t is your particle velocity. So you get this legendary equation, particle velocity, and omega by k is the wave velocity. So minus the wave velocity multiplied by del y by del x, which is the slope of yx graph. So particle velocity is negative the wave velocity multiplied by the slope of yx graph. That is what you have to remember. That means if the slope of the yx graph is negative, then the velocity of the particle would be positive. Astounding result. Do we understand this? So from there, you can understand if the velocity of the particle is positive or the velocity of the wave is negative. Now, if velocity of the particle is positive or velocity of the particle is negative because it's negative slope of the graph. Let me see if I can find some what some find out some. Okay, I will draw the diagram and ask you. Have you written this down, everyone?
Yes, sir.
A very important result. Now, how are you going to use this result, or how are you going to understand what is happening? And this is very, very important graph that I'm going to draw. So what I'm going to draw is a graph of y versus x. Now I can only draw this graph of y versus x at some constant time. So what is this graph going to give me? What is this graph going to give me? Huh? What is this graph going to give me? What will this graph give me? Salman Khan or Shah Rukh Khan? What will this graph give me? If I draw a graph between y and x, what does this graph represent? What does this graph tell me? What does this graph tell me? If I draw a graph between y and x and it is drawn like this, what does this graph tell me? It gives me what?
Shape of the wave, sir.
It gives me the shape of the wave. Shape of the wave means it is giving me the position of all the particles of the wave at one given time. Do we understand this?
Yes, sir.
Okay. Now it comes the most important aspect. Let me make some points. O, A. There's some random points I have taken for one particular reason. C and D, and I am only taken one wavelength. Let us, if I understand one wavelength, I will understand the other wavelength because the wave is going to get repeated. Now, there are particles between O to A, and right now we are seeing the position of all these particles. Yes or no? Now, the question is, how are these particles moving? Are they moving towards their mean position or are they moving away from their mean position? If the velocity is positive, we will understand that they are moving away. If the velocity is negative, that means downwards, we will understand that they are moving towards their mean position. Do we understand this?
Yes, sir.
Between O to A, O to A, there are infinite number of particles. How are they moving? Are they moving? Remember, this is their mean position. That this horizontal line is their mean position. Do we understand this? This horizontal line is their mean position. We understand this? And right now they are displaced at different points. Where are they moving? Particles between O and A. How are they moving? Huh? We don't know, sir. How do I know, sir?
Away from mean position, sir.
They are moving away from the mean position. That is the right answer. How did you get it? Sir, they are above. Therefore, they are moving away. Hai yes or no? They are not moving away. They are actually moving towards the mean position. And the particle here is at rest. How did I get this? Because the particle velocity is negative of the slope of the graph. Here from O to A, the slope of the graph is positive, and therefore velocity of the particles is negative. So particles are moving towards the mean position. Do we understand this, or this has gone above it saying bye bye?
Yes,
Sir,
sir.
हो गया.
Yes.
हो गया, sir, हो गया. Done. You understand this?
Yes, sir.
Between A to B, how are the particles moving? A to B, there are infinite number of particles. What I am shown in this graph is only their position. Now, forget about this. Think about SHM. Particle is at mean position. It may go away from the mean position. It may go towards the mean position. From O to A, all the particles are towards right. Please try to understand what I'm saying. From O to A, all the particles are towards right of their mean position, but they are moving towards the mean position. Do we understand this?
Yes, sir. Yes, sir.
Pakka? A to B. Nah, we don't know, sir. A to B.
Sir, A to B also towards
Okay, I think we have overshot the time for today. I did not look at that time. So I'll give you time till tomorrow to tell me all the answers. Do we understand what we have discussed?
Yes, sir.
Go back home, think about it. If you understand this, everything else is done. So this is the most important aspect of a wave. Okay? So go back home and see what we have done. I'll see you tomorrow in tomorrow's class. Okay? Take care and bye bye.
Thank you, sir.